In this video, you will learn how to reconstruct estimates of stature based on formulas that were derived from Trotter and Kleiser during the Korean War, of the Korean War dead. I'll explain the chart as we go through a little bit more. You'll see that there are white males, black males, white females, black females, Asian males, and Mexican males. These are ancient terminology. Again, European, if you refer back to the sheet on racial characteristics or population characteristics, these would be European, African, Asian, and that would be the only three populations that we deal with. Mexican males would be included in with the Asian population. Again, refer back to that video on race. Don't pay attention to the statures that are on there, stat 1, stat 2, stat 3, etc. These are just reminders for me from a student project that I did very long ago, in which I actually computerized the formula so that you can pop it out real quick through program. We have programs that do that now, but we still like to have you guys do this by hand so you get an idea, feel for it. If you look here, you'll see these regression formulas show different bones. I'll start with the white male up there. Fem, Fib, Tib, Hum, Rad, and Ulna. You should guess what those are, or actually I should say you should know what those are after your midterm. Of course, femur, fibula, tibia, humerus, radius, and obviously the ulna. These are listed in their most accurate. So the bone that is highest on the list is actually the most accurate estimation you can make for stature. If you move across to the black males columns, you can see that the tibia is actually more accurate, then followed by the femur, the fibula, the radius, the ulna, and finally the humerus. Each one of these is going to vary accordingly. The principle behind this is that when you have a set of bones that you're looking at, if you're going to estimate stature, and I'll give you an example of that as we move on to this, you're not going to have all of the bones of the skeleton in many cases available. If you do, great. You're not going to have them all in fragmentary or in less than fragmentary condition, in perfect condition. Often enough, the bones might be fairly fragmented. Now again, this is introductory level stuff. There are ways in which you can compensate for this stuff, but it's not the concern of this class. In this sense, you want to pick the best bone. So for our European male, for our white male, if the ulna, the radius, and the humerus are present, the best bone would be the humerus. You don't have a femur, you don't have a fibula, you don't have a tibia, so you can't use those bones. The bone should be in complete condition, if possible, or at least nearly complete, at least along its length. I always go back in my mind to an old program, Quincy Medical Examiner, in which his assistant came in and said that they found a bit of the femur, and he got very excited and said, oh, from that little bit we should be able to reconstruct stature, which caused me to slap my forehead. You cannot do it with incomplete bone. Incomplete long bones cannot give you stature. All right. So what are we doing here? Going through this, we're going to pick the best bone in my example, and then we're going to do the math behind this. I'm going to give you an example of how the math is done and how the problem should be solved, and again, for the final. In this instance, we will give you as much information as possible so that you can do this without having to do all these measurements. So we will actually give you measurements so that you can go through this. If you look at the charts, you can see that what's important is to understand what population, European, African, Asian, and what biological sex, what biological component makes up the skeleton or the individual that you're looking at. You have to have both the race, the population, and whether they're male or female in order to do this. In order to estimate stature, you're going to use something we call osteometric board. Sounds really fancy, but all it means is bone measuring board. Looks like one of those old shoe measuring devices that we had at one point in time before we started picking our own shoes. And you can see here across that the ruler has millimeters. We're going to have to make a conversion to centimeters once we do the measurement. Depending on what you have, how can you tell the race or population? Really, you need the skull. If you don't have the skull, not going to happen unless we give you that information. How can you tell male or female? Once again, the skull or an innominate can give you a good idea of whether it's male or female. If those are absent, I'm bringing the femur in here. I'm not going to really do the measurement on this. I'm just going to show you. You can bring the femur in, head of the femur, you can measure. Refer back to the other video on sexing. And in this case, we have a male. For the purposes of the exercise, we're going to say that this is an Asian male. If you guys are practicing this at home, you can do it without bones by simply making up the different individuals and making up the different lengths of the bone. So to use the osteometric board, again, we're going to put the bone here and we're going to rock the bone back and forth because we want the maximum length. And you can see, hopefully, that the board is moving a little bit. What I get here in the end is 44.2 or 442 millimeters. Now I'm going to automatically convert that in my head because I've done this forever. But what you guys need to do is move the decimal point over 1. So 442 is actually going to be 44.2. Now we'll go back to the dot cam and I'll show you how to go through the how to go through the formula. I've covered up, again, the femur here. We did not have a fibula. We did not have a tibia. We did have a femur. We did have a radius and an ulna, but they're not the highest on the list. So here for the femur, you can see that it says 2.15 times the femur length plus 72.57 plus or minus 3.8. So I'm going to write that down here. 2.15 times 44.2 plus 72.57 plus or minus 3.80. That's our formula. Simple, straightforward math. You're going to do what's in the parentheses first. 2.15 times 44.2 is going to give us 95.03. I'm just going to keep the formula going. 95.03 plus 72.57 plus or minus 3.80. Next thing we're going to do is add both of those numbers. Both of those numbers together is going to give us 167.60. And again, that's plus or minus 3.80. We want the maximum, the mean, and the minimum estimation here. We've already got the mean. It's 167.60. In order to get the maximum, we're going to add 3.80, which is going to give us 171.40. And we need to minus 3.80 from the mean. Be careful when you do this. If by mistake you minus that from the 171, just minus 380 again, and you should get 163.80. That's the start of the bracket that you need to have when you solve this. In order to turn these from metric into something that law enforcement agencies here can deal with, we're going to convert it from metric to standard. We have a conversion factor of 30.48. So you're going to divide by 30.48. In this case, you're going to get 5.62, 5.49, and 5.37. What you're doing is you're converting from a base 10 to a base 12. Very, very interesting in conversion. But 30.48 seems to do fairly well and keep it within a possible range. Now what you'll do with these is, rather than go one step further and move them into that 12 range, we're just going to go ahead and say that this is 5 foot 6 inches. And that actually works out to that. We're going to say this is 5 foot, rounding up, 5 foot 5 inches. And rounding up again, this is 5 foot 4 inches. Those actually work out pretty close to the base 12 numbers. And again, there's your bracket for the final. So now you've estimated the stature of this Asian male to be between 5'4" and 5'6". Again, this is just an example. Whether this is, really the range you're going to get with any other situation, who knows? But in this case, following this with the example we set out, this is going to be your range. So this individual is 5'4" to 5'6" in estimated stature.